Hi, welcome to topNotch Tutorials. In this session, we will continue our discussion of binary and decimal number systems, which we have started since our lecture number 4. I request everyone to please watch the previous session and then resume watching this video as the basics are covered in the previous one. Okay, so let us once again consider decimal to binary conversion of the following numbers. We have listed down numbers from 2 to 7 and we have calculated their binary representation using the double-double method. Okay, so let us consider few numbers. We have listed down numbers from 2 to 7. And there is one peculiar thing which we can observe in these numbers. Let us consider 2, 4 and 5. This slide shows the double-double method which is executed over number 2, 4 and 5. Now if we carefully observe these numbers, on the right hand side we have the binary number which is formed from MSB to LSB, like from downward direction to upward direction. The LSB of every number is 1 or 0 depending upon whether the number is even or odd. Like as we can see over here, number 4 is having its LSB as 0 while 5 is having its LSB as 1. Same applies for number 2 as well. And one more thing which we can observe over here is that after the first, we can say, breakdown of number 4, the remaining steps are repeated same as for the number 2. Same applies for number 5 as well. Let us consider 3 more numbers, 3, 6 and 7. For 6, as we have said, the LSB is 0. And for 7, the LSB is 1, depending upon whether the numbers are even or odd respectively. And the remaining stages are same or repeated as of for number 3. So with this understanding, we can say that in this slide, we can see that 5 and 7, as they are odd numbers, they are having their LSBs as 1, while 6 is having its LSB as 0. Some notable inferences which we can draw from the table besides is that the remainder will be 0 or 1 based upon whether the number is even or odd. Remainder as in the LSB we can say. Even numbers will have quotient half of the given numbers, while odd numbers will have quotient half of 1 less than the given number. Now what do we exactly mean by this statement? If we consider any number, let's say 5, if we divide it by 2 as we do in double-double method, dividing it by 2 will yield us quotient 2 and remainder as 1. Now the relation which we can have from this number is that if the number is odd, like 5, 7, 9, the remainder is always going to be 1. And the quotient will also have a direct relationship with that number. The quotient will be half of the given number, or for even numbers it would be half of it, and for odd numbers it would be half of one number less than that number. So if our number is 5, then its quotient would be half of 4. If our number is 3, its quotient would be half of 2, that is 1. If our number is 7 or 9, its quotient would be half of 8 or 6. And likewise. So if it is an odd number, we have to subtract 1 from it. We have to decrement that number, and its quotient would be half of that number. And if it's even, we just have to divide it by 2. This is what this table means. Okay, so here is a simple algorithm which we have developed with this understanding. We'll first consider our number. Check whether if it is even or odd. If it is even, we'll divide it by 2, write 0, and check whether the divided number is 0 or not. If it is 0, then we'll terminate the process, and if it is not 0, we'll again go back to the previous stage and continue the process until the number is decremented to 0 and the process stops. So we'll consider an example which will make things clear for us. Let us take number 20. Now, as we know, number 20 is an even number. So we'll divide number 20 by 2 and we yield 10. We'll write down 0 as our LSB and we'll check whether it is 0, which it is not, and we'll go back to our previous stage. And we'll repeat this process until the number is decremented to 0. So again we continue this process for number 10. We'll check whether if it is even. Yes, it is even. We'll divide it by 2. We yield 5. We'll write down 0 once again. No, the number is not 0. So it goes back to the previous stage. Now the number 5 is an odd number. So if it is an odd number, we will subtract 1 from it. As we can see over here, if it is 5, we'll subtract 1 from it to yield 4. And we'll divide the 4 by 2, which yields 2. Now we will write down 1. Remember, for odd side, we'll write down 1, and for even, we'll write down 0. Check whether the divided number is 0. And as it is not 0, we'll go back to our previous stage. Now the number is even once again. We'll divide it by 2, we get 1. We will write 0. As it is not 0, we'll go back to the previous stage. 1 is odd. Subtract 1 from the even number. Now that gives us 0. Dividing 0 by 0 keeps it 0. We will write down 1. And as it is 0, we will terminate our process. And there we have our binary representation of number 20, which is 10100. Let us consider another example. Let us take number 41. This number 41 has been solved in double-double manner in the previous session, that is lecture number 4. So we'll directly refer to our new method or our algorithm and try to build up the binary number orally. So as number 41 is an odd number, we'll subtract 1 from it and divide it by 2. That gives us 20, and we'll write down 1. We are following this algorithm, by the way. Now 20, as it is even, we'll divide it by 2. That is 10. We'll write down 0, and as 10 is not equal to 0, we'll continue this process by checking whether it's even or odd. We'll divide by 2. We yield 5. We again write down 0, and the process continues. We just have to consider whether the number divided is even or odd, and depending upon that, we have to take the decision to subtract 1 from it or not. And if the number is even, we will be considering 0, and if it is odd, we will be considering 1. And this is how Subsequently, we'll go on building up our binary number. So as it is 5, we'll have to subtract 1 from it, which yields 4. We'll divide the 4 by 2, which is 2, and we'll write down 1. We check the number, whether it's 0 or not, which it isn't. And as 2 is even, we'll directly divide it by 2. We'll write down 0. We yield 1, and we repeat the process. And now we get a 0. When you subtract 1 from 1, you get 0, and dividing it by 2, you again get 0. But do not forget to write 1 in this stage. That is very important. And this is how we reach our final answer, that is 101001, which is binary representation of number 41.